Hey guys, welcome back to another video with Mr. Leith, where we make math easy to learn and understand. Alright, so our aim for this video session is basically to focus on the multiplication of fractions, where our objectives are basically to allow our viewers to be able to multiply two fractions, multiply a whole number and a fraction, and also being able to multiply mixed numbers. Alright, so with no further ado, let's get right into the video. Alright, so multiplying fractions is basically a 2 to 3 step method, which involves multiplying the numerator, multiplying the denominator, and simplifying the fraction. Alright, sometimes we basically simplify before we multiply the numerators and the denominators. Alright, and simplifying basically involves dividing both the numerator, like we're reducing fractions, but it have to be a numerator and a denominator. It doesn't have to be the same numerator of the same fraction along with the same denominator of the same fraction. It can be the opposite of each. Alright, so the numerator of one along with the denominator of the other, along with the denominator of one along with the numerator of the other. Alright, so once we get into it, yeah, basically so what we're talking about. So to start, let's look at having something like this. We have 2 over 3 being multiplied by 4 over 5. Alright, so we're gonna go the normal procedure, is basically multiplying then simplifying after. Alright, we already know that numerators are basically the top numbers while the denominators are the numbers underneath. So if we're supposed to multiply this, we're gonna multiply the numerator with the other numerator. Alright, so numerator of one fraction along with the numerator of the other fraction, which is the 2, which is 2 over half right here, so, and the 4 over half right here, so. So if we multiply 2 times 4, we know that for sure that's going to represent what's in the numerator. And for the denominator, we'll be multiplying whatever we have down here, so in the denominator. And that's going to be a 3 times a 5. So if we're supposed to simplify this now, 2 times 4, we know that for sure that's 8. And 3 times 5, that is 15. Alright, so remember we say 3 steps: multiplying the numerator, multiplying the denominators, and then we reduce after. Alright, not all fractions can be reduced, because remember, once one alone can go into the fraction, that means it cannot be reduced. So 1 alone can go into it without leaving a remainder. It cannot be reduced. Alright, because the same thing would I get if we divide n fraction by 1. Alright, the only number that can go into 8 and 15, only common number that can go into 8 and 15 is only 1. So this would have been our answer for this we'll have right here. So let's look at something else. Let's look if we have a 1 over 7 times 28 over 5. Alright, so if we go ahead, I will do our normal procedure, which we multiply the 1 times the 28. That's going to give us 28. Alright, and then if we multiply the 7 times the 5, that's going to give us 35. Alright, if we decide that we're going to break down this, alright, remember, our aim is this can be broken down because other number than 1 can go into it. Alright, remember, always try to use the largest number that can go into both our numerator and the denominator. It helps a lot. Alright, but if you can figure out a smaller number, that's also fine. Alright, so looking at this, I can see that 7 can go into both of them. 7 can go into 28, and 7 can also go into 35. So if I divide this by 7, I'm going to say 7 to 28, I'm going to get a 4. Then if I say 7 35, I'm going to get 5. So that's going to leave me with a fraction of 4 over 5 as my final answer. Remember, I told you that it can be a case where you don't necessarily just multiply and then simplify after. You could actually simplify first, then multiply after. This is what I mean. So let me just rewrite the 1 over 7 times the 28 over 5. Alright, and I actually like this method better because sometimes I get some big numbers who likes to multiply big numbers. Alright, so I really like to look if anything can be broken down first, then I do the multiplication after. So looking at this, again, I told you that is either, let me do some highlighting. So you can work with a numerator and the denominator. So you can work with a numerator and the denominator. You can work with a numerator of one fraction with the denominator of the other fraction. Cool. You can work with the denominator of one fraction along with the other numerator of the other fraction. Whilst you can work with the numerator of this fraction with the denominator of this fraction. Alright, so once you're working with a numerator and a denominator, you can always do any form of simplification. You cannot, and let me say cannot, simplify this way or this way. Alright, all thing you do crossway like this is if you are multiplying. Alright, so don't do any form of simplification that way. Alright, so let me check this first with this. Alright, is 1 and 7. We know that all number can go in a 1 and 1. Alright, so we know that that's not necessarily gonna work. Alright, 28, the 5. Alright, there's any number other than 1 that can go into both 28 and 5? No. Only 1 alone can go into it. Alright, so that's not gonna work. Let's try. We already know that 1, anything with 1 is always gonna be 1 because there's no number greater than 1 in this case that can go into 1. Alright, so let me look at the 7 and the 28. Alright, looking at that, we know that we can actually break that down. Or we know that because I know that our other number other than 1 can go into 7 and 28. 7 only have two factors, 1 and itself, which is 1 and 7. Alright, and 7 is also a factor of 28. So I know that you can go into it without leaving a remainder. So all I've done is that I've just said, alright, 77 is gonna go 1 time. Let me keep it in ready. It's gonna go 1 time. And 7 into 28 is gonna go 4 times. So this new numerator that I now have is now a 4 now. It's no longer 28 because I've broken it down. And this denominator down here so is now a 1. Alright, it's now a 1. Numerator operator is now a 4. Alright, so when I'm doing my multiplication now, because I've now simplified everything that I needed. When I'm doing my multiplication now, all I'm doing now, I'm going to multiply the 1 times the new numerator now, which is the 4. And for the denominator, I'm going to multiply a 1 times the 5. Alright, so any number that you have now received when you break down the fraction, that's the number that you're going to be multiplying with. Alright, and that's just going to leave us now with a 1 times 4, that's 4. 1 times 5, that's 5. Alright, so if you realize, we still get back the same answer what we get over here. So either we simplify first, then multiply across. Same answer we get if we multiply across, right? And then we simplify after. Alright, and multiplying across means I multiply a numerator and a numerator, denominator and a denominator. Alright, that's multiplying across. So I multiply numerators with numerators, denominators with denominators. Alright, that's gonna give me a number, and if that fraction can be broken down, then I'm gonna break it down. Alright, or simplify it. Alright, whilst I could have done it this way over here, so which I've basically simplified first. So I look if any numerator at all and denominator have something in common. So it can be the numerator of one fraction with the denominator of the other fraction, and vice versa, or the numerator and denominator of one fraction. Just look if they have anything that can be divided into each other. Anything common that can be divided into each other without leaving a remainder. Alright, and then after that now, we just multiply across to get our final answer. Alright, so doing that method, I believe that it helps. Once you have simplified everything correctly, I believe it helps when you're multiplying, because we get easier number for multiplying now. 1 times 4, 1 times 5. Alright, let's look at if we have this now. We have our next one. Let's say we have a 3 over 4 times a 6 over 9. Alright, I want to do this both ways. So let me go to a new page. So let's say same number. So let's say we have the 3 over 4 times the 6 over 9. Alright. So I'm going to do it the normal way, which is basically multiplying across and simplify after. Alright. So remember, I'm going to do it both ways. So multiplying across, I'm going to say a 6 times a 3, and 6 times 3, that's 18. Numerator, numerator, denominator, and denominator. Now 4 times 9, that's 34. Alright. So that's me right here. So cool. Looking at this, alright, I know that 34 and 18 can both be divided by 9. Alright? If you cannot figure out the biggest number, both of these are even numbers. I can use 2. Alright? So if I break down with 9, I would just say 9 into 18 goes 2 times. 9 into 34 goes 4 times. Alright? And then after that now, I just break down and say, alright, 2 into 2 goes 1 time. 2 into 4 goes 2 times. Alright? While 9 is not even the largest number, 18 is actually the largest number. 18 into itself 1 time, 18 to 34 goes 2 times. Alright? I could have done it like that and I'll get half as my answer. Alright? So again, I could have said 18 to itself 1 time, 18 to 34 goes 2 times. I'm going to get half as my answer. Alright? But sometimes we don't pick up that right away. Alright? So what I could have done is that both of these are even numbers. So let's break it down step by step. So I said 2 into 18 goes 9 times. Alright? And 2 into 34 is going to go 18 times. Alright? So I'm now left with this. And 9 over 18. This still can be broken down. Alright? This still can be broken down. But can go into 9 and 18. That's very simple. 9 itself. So 9 to itself 1 time. 9 into 18 goes 2 times. So now I'm left with a half as my answer right here. So, and again, if I've figured out, or if I've figured out that 18 can be divided into 34, I could have just went right away. 18 into itself 1 time, 18 into 34 2 times, and I'll get my half right away. Alright, let's look now. If we actually did do the simplification before we actually multiplied, so let me write about the 3 over 4 times the 6 over 9. Alright, if I did any form of simplification before, alright, I would have basically, believe that it would make my life easier. Alright, so looking at this straight away, we see that 3 can go into 9, while also there's a common number of 2 that can go into 4 and 6. So if I'm supposed to break it down that way, while we can also see that 6 and 9 can be broken down. Alright, so let me go ahead and do it. So I'm gonna work with the 6 and the 9 first. I'm gonna write that down vertically first. Alright, so 6 and 9, common number 3. 3 can go in both of them. So we say 3 into 6 goes 2 times, and 3 into 9 goes 3 times. So this new fraction of my over here is basically a 2 over 3. And if I want, I can rewrite it. So I now have a 3 over 4 being multiplied by a 2 over 3. Why? Because I've now reduced the 6 over 9 to a 2 over 3. Remember, reduced fractions basically still represent the fraction. It's just that it's reduced. Alright. So with this now, I can see that I can still reduce these fractions. Alright. And let me not use reduce, but simplify it. Alright. In such a way that numerators and denominators can be simplified. So 3 can also go into 3. So I'm going to put some highlighting for show you. 3 can go into 3. Whilst 2 can go into 4. Alright, so I can do that reducing. Alright, so I'm saying 3 into 3 goes 1 time. 3 into 3, 1 time. Alright, so break that down. That is me simplifying like that. Alright, in a diagonal way. Alright, 2 into 2 goes 1 time. And 2 into 4 goes how much time? 2 times. Alright, you see me there? I've just simplified that fraction. So now, I'm going to have a 1 times 1. This one right here, so. This one with this one. And this 2 with this one right here, so. Those are what I'm going to multiply now. So 1 times 1 is going to give us 1 in the numerator. 2 times 1 is going to give us a 2 in the denominator. Alright. I believe that it's actually easier for me to basically simplify first, then I multiply after. Alright, because you give me less number or smaller numbers to actually multiply. Alright, especially in our cases where we're probably doing the paper 1 exam where we don't have our calculators. We try to get the numbers as small as possible, but we know that once we don't have our calculator, we can basically sit out and multiply. Alright, so this would be my answer in this case right here. So let's look at another example again. Let's say I have 3 over 5 times 15 over 21. Alright, so that is me right here. So 15 over 21. So this right here, so I'm gonna do it both ways again. So I'm gonna write it back over here. So I'm gonna do it both ways. So let me multiply across first. 3 times 15, that's 45. Alright. 5 times 21, that's 105. Alright, so that's what I have right here. So this can be reduced. What tell me straight to say this can be reduced? Because both of these numbers, 45, 105, they can both be divided by 5. I know that for sure. So I could have started and just break it down with 5 right away. Alright, but I know that I can use 15 to break down this fraction that I have right here. So 15 can go into 45, 15 can go into 105. Alright, so 15 into 45 goes 3 times. And 15 into 105 goes 7 times. So my fraction that I'm going to get right here, so it's going to be a 3 over 7. Alright, if you have used smaller numbers, like for example, 5, you would have said 5 into 45. So let's write it back down here, so just to show you the breakdown. 45 over 105. So I said that if you used 5, it's different thing. Now, if I use 5 into 45 goes 9 times, and 5 into 105 goes 21 times. Alright, so I'm now left with a 9 over 21. And we know that 9 and 21 have a common factor of 3. So 3 can go into 9 3 times, and 3 can go into 21 7 times. So my new fraction that I'll get right here, so is still a 3 over 7. Alright, so either way, same thing we get. But let's look at if we actually simplified first. So we do simplifying first, then we multiplying after. Alright, so we look again. We said these can break down. So we say, alright, let me break this down. I'm gonna say 3 into itself 1 time, 3 into 21, 7 times. Cool. 5 into itself 1 time, 5 into 15, 3 times. Looking at this, we know that nothing else can break down. Alright, nothing else at all can break down. So up at the top now, I'm left with this. I'm left with a 1 and the 3. And 1 times 3, that's going to give me a 3. Down at the base now, denominator, I'm left with this. 1 and 7. Alright, so 1 times 7, that's giving me a 7. Alright, and again, same 3 over 7 that I get up here, so same 3 over 7. Let me get up here, so at the same 3 over 7, break it down using 5, break it down using the 15. Alright, so no matter where you go, at the same root, at the same place, the destination I take with. Each root, same destination. Alright, so again, when you're multiplying two fractions, alright, it's a 3-step procedure. Alright, multiply numerator, denominator. Multiply numerators first, let me put it that way. Multiply denominators, then simplify after. Or you could rearrange it in such a way that you simplify first, then multiply numerator and numerator, then denominator and denominator. You get your answer. Whichever method works for you, let it work for you. All right. You don't have to use exactly what works for me. All right. I just give you my belief as to why it works for me because I think that it's better to multiply with smaller numbers after. So I face my biggest challenge is basically to break it down. Because if you multiply first, you know that you're gonna get bigger numbers. All right. We know that for sure. I will get bigger numbers. All right. And then if you figure out what's the largest number that can go into both the numerator and the denominator, it can be a challenge. All right. It can be a challenge. All right. Whereas if the number is not a straightforward answer, if it's some hard number. All right. So I believe that it's easier to break down before I do any form of multiplication. So I get the number small. So if I multiply it, it's not a large number as it would if I've multiplied originally first, then try to break down after. So let's look at if we decide that we're gonna multiply whole numbers and fractions. All right, so let's look at this whole number, 5. 5. So we have 5. All right, and we're gonna multiply that whole number by a fraction of 2 over 7. All right. When you're given a whole number, you can make every whole number or any whole number a fraction by putting it over 1. If you have watched my previous videos, you would hear me establish that entirely already. All right. Every whole number can be represented as a fraction or written as a fraction by just putting it over 1. So putting 1 as the denominator. All right. So let me just use blue just to show that I've now changed that whole number to a fraction like that. All right. So now we basically have something resembling what we just did previously. All right. And that's always our aim. Just try to get back what we actually learned before. All right. So, kind of throw away off in any way. All right. So me get it to look like, oh, we just here work with it. All right. Nothing right here can be reduced because 1 can go into 2, yes, but we still get back 1 and 2. But there's no common number that can go into 5 and 7. And we cannot simplify vertically, which is the 2 and the 7, the 5 and the 1. All right, so I'm just going to multiply across. All right, the 5 times the 2, that's going to give me a 10. And then a 1 times a 7, that's going to give me a 7. So my answer right there, so, is just going to be a 10 over 7. All right, let's look at if we get the next one. If we get a 7 times a 10 over 15. All right, looking at this again, can make the whole number a fraction by just putting it over 1. All right, then now look if anything can be simplified. All right, so 7 can go into 15, 1 can go into 10, but at the same thing, it'll give back 10 and 15. All right, that can be broken down. All right, so I'm gonna say broken down using 5. So it's a 5 into 10 goes 2 times, while 5 into 15 goes 3 times. So that new fraction we have is a 2 over 3. All right. Now that we have 2 over 3 over here, so it still can simplify with nothing because 3 can go into 7 without leaving the remainder. So we just have to multiply with this what I have right here. So, all right. So it's a 7 times 2. That's going to give us a 14. While a 1 times a 3 is just going to give us a 3. So our answer would be a 14 over 3, and that cannot be reduced. All right, cannot be reduced. So leave it as it is. Let's look again. If we had 10 times a 3 over 25. All right, so that is us right there. So again, make the whole number a fraction, put it over 1, then we'll just do our normal multiplication. Oh no, but all right. So we'll try to simplify first. Anything can be simplified? Yes, the 10 and the 25. What number can go into both of them? 5. All right. So 5 into 10, 2 times. Well, 5 into 25 goes 5 times. All right. No form of reducing can be done again. So let's multiply across. 2 times a 3. That's going to give me a 6. 1 times a 5. Going to give me a 5. And that would have been my answer right there. So, all right. Lastly, let's look at the next one. Let me just turn it around this time. So let me say I have a 3 over 5 I'm going to multiply that by 8. Alright, in this case, start out by doing the normal thing again, putting it over 1. In this case, as I've said, is that check to see if anything can be reduced. Looking at this right now, nothing can be reduced. I'm just going to multiply across. 3 times 8, that's 24. And 5 times 1, that's 5. And that would have been my answer. Right here, so. Alright, those are our answers. Alright, so again, are the same thing. Alright, it's just that this time, all thing we're done is just put the whole number over 1. And then we just get back to our 3-step. Simplify, multiply numerator, multiply denominator, you get a fraction, you find out a fraction. Alright, multiply numerator, multiply denominator, simplify after. Whichever way works for you, or you believe that it's actually working for you, or it's easy for you, you work with that. Alright, remember, math does not only works one way. Many paths, one destination. Whichever path is easy for you, you go on that path. Alright, and that's just basically how we look at fractions. Alright, let's look at if we're multiplying mixed numbers. Alright, so to start, let's look at this example. We have 1 and 1 over 2 times a 2 and a 2 over 3. Alright, our aim with this is to basically get it to look like what we were working with before. What we're working with before are just normal fractions. Alright, either proper or improper. Alright, either way set, we know that we still can work with it. Simplify, multiply numerator, multiply denominator, get the final answer. Alright, so when we were doing addition and subtraction of mixed numbers, alright, what was the first thing we have done before we even do anything at all? We change the mixed number to an improper fraction. And that's what they do. So that's the same exact thing we're going to do right here. So we're going to change these mixed numbers to improper fraction. Or we'll do that again. 1 times 2. Then we add the numerator. Keep the denominator. Alright. If you don't remember how to change mixed numbers to improper fraction, I've had a video. Alright. I think it's lesson 2. Alright. So 1 times 2, that's 2. And 1 up there, that's 3. So it's going to be a 3 over 2. Alright. Times 2 times 3, that's 6. 6 and 2, that's 8. So 8 over 3. So that's what we have right there. So let's go now. This we have right now. So these are the improper fractions for these mixed numbers up here. So those are representing them. Alright. The numbers change, but the value doesn't change. Alright. Again, simplify, multiply numerator, multiply denominator. So let's simplify first. We know that, or we can clearly see that the 3 and the 3 can be simplified. So it's a 3 into itself 1 time, 3 into itself 1 time. Alright. We'll do the same thing with the 2 and the 8. 2 into itself 1 time, 2 into 8 goes 4 times. Alright, so let's look at what we have now. In the numerator, I have a 1 and a 4. And 1 times 4, that's 4. In the denominator, I have a 1 and another 1. So 1 times 1, that's 1. Anything over 1 is what? Is the original number that's in the numerator, which is a 4. Alright, so anything over 1 is the same whole number. Same like what we did do before. Remember? We change the 5 to a fraction by just putting it over 1. Because it still represent 5. We change the 10 to a fraction by just putting it over 1. Because it still represents a 10. So anything over 1 still represent the whole number that we have. What is over 1? Alright. Let's look at if we have an next fraction now. Let's look at if we have we have 3, 2 over 3 times a 12 over 33. Alright, let's look at if we have something like this. Having something like this, it doesn't make a difference. Even though you're seeing only one mixed number, change that one mixed number. Alright, so 3 times 3, that's 9, 9 and 2. That's how much? 11. 11 over 3. Alright, times. We're about the same 12 over 33, because we cannot do anything to that. That's already a fraction for us. Alright, from this now, do now one 3 step. We can see that clearly. We can see that things can reduce right here. So 3 into itself, 1 time, 3 into 12 goes how much time? 4 times. Alright, 11 into itself 1 time, 11 to 33 goes 3 times. So what that leaves us with now, a 1 times a 4 in the numerator, that's 4. A 1 times a 3 in the denominator, that's 3. And this is our final answer for this right here. So, alright, we can look at more examples. We have 5 over 12 times a 4 and 2 over 3. Alright, we know that we cannot do anything to this as yet, so that's going to write it back. Times a 4 times a 3, that's 12, and 2, that's 14. So 14 over 3 as our improper fraction right there. So all we need to do now right here, so check to see if anything can be reduced, then we multiply across. Alright, 5 and 3, nothing cannot be reduced. Only common factor right there, so is a 1. So look at the 12 and the 14. What can go into both 12 and 14? Alright, even numbers, so we know that 2 can go into them. So 2 into 12 goes 6 times, and 2 into 14 goes 7 times. Alright, nothing else cannot be reduced. Don't look at the 6 and the 3 and tell me so they can reduce enough, because both of these are in the denominator. Alright, if one was in the numerator, then fine. Alright, but we cannot reduce them right there. So just have to multiply across now. So 5 times 7. 5 times 7 how much? 35. And then 6 times 3. 6 3 is 18. And that would be our answer for this question right here. So final answer right there. So let's look at one last one. One last one, which is basically us doing this now. 4 and 1 over 3 times a 3 and a 2 over 5. Alright, let's look at this. Both of them mixed numbers, change into improper fraction. 4 times 3, that's 12 and 1. 13 over 3 times 3 times 5, 15 and 2, that's 17. 17 over 5. Alright, looking at this, we know for sure nothing cannot be reduced right here. So, alright, so all we need to do, I just multiply across. So I just say 13 times a 17, that's going to give me a big number, a large number, which is 221. If you don't know this, just use a calculator. Alright, nothing cannot be reduced, that's how we end up with a big number. And then easy, 3 times 5, that's 15. Alright, so there, and that would be our answer for right here. Alright, nothing cannot be reduced right here, so nothing cannot be reduced. So we'd have to just leave our answer as this right here. Alright, and that's just basically how we multiply fractions. Alright, just remember, multiplying fraction take into consideration 3 important steps. Alright, multiply numerator, multiply denominator, then simplify. Or we'll simplify, and we'll always simplify numerators and denominators. Remember that. Alright, so it have to be a numerator and a denominator before you do anything, for you to simplify any at all. Alright, it doesn't have to be the numerator and denominator of one fraction, but the numerator of one along with the denominator of the other. Alright, or the denominator of one along with the numerator of the other. Alright, you just have to be a numerator and a denominator. Alright, for you to reduce it. And reducing basically involves dividing a number, a common number, into both the numerator and the denominator. So it must be a number that can go into it without leaving a remainder. Alright, otherwise, once you simplify, they will just multiply the numerators, multiply the denominators, and get our answer. Alright, 3 steps. 3 easy steps. When you have a whole number now, let's put that whole number over 1. Do your normal 3 steps again. Getting a mixed number, change the mixed numbers to a improper fraction. Then after that, 3 steps again. Simplify, multiply numerator, multiply denominator, get a final answer. And that's just it. Don't want common misconceptions. Sometimes, because you have learned LCM already, right? When adding and subtracting fractions, sometimes people get mistaken and ready to find LCM for multiplying. It's a common thing. As much as though it's simple, it's common. Alright? So you only find LCM for adding and subtracting fractions. Never for when you're multiplying them. Alright? You only find LCM when you're adding and subtracting. We need to remember these things. Alright? And persons are doing it in their exams. Don't do that. Just remember when you use certain things. When it comes down to multiplying fractions, only thing we need to remember are 3 steps. Simplify, multiply numerator and numerator, multiply denominator and denominator. Get your final answer. Ensure your final answer is in its lowest term. Alright, that means that no other number than 1 cannot be divided into both the numerator and the denominator. Getting a mixed number, procedure the same across all the basic operations, which are the multiplication, addition, subtraction, division. Once I get a mixed number, you need to ensure that you change the mixed numbers to an improper fraction first. Alright, and from that, then you can go into your normal steps, which is simplifying, multiply numerator, multiply denominator. Alright, so that's it. Alright, I hope this video makes the content a bit clear as it regards to multiplying fractions. I believe that I've covered everything as it regards to multiplying fractions. If you believe that there's something that I should have covered, you just leave it in the comments. Alright, thank you again for watching. Like, share, and subscribe, and I'll see you guys in the next video.